Welcome back to Parent Tutoring. This is Rachel Theus, one of the Parent Involvement Coordinators and Instructional Coach, and I'm here with Simone Darby, our Math Coach and the other Parent Involvement Coordinator. If you're new to Parent Tutoring, thanks for attending. These will be held every other Monday for the next few weeks, and you are also able to come to in-person tutoring at the library between 3 and 4 o'clock every other Monday. If you have any questions, you can feel free to reach out to us either by email or calling the school, or you can jump into the chat if you're on this. Some upcoming events that we've got in the next couple of weeks. We've got Makeup ACT for our juniors on Tuesday, April 7th. Any junior who missed the original ACT date back in March is going to need to be here on the 7th to make that up. Also, our middle school students will be doing ACAP testing coming up next week too. That'll be held the 8th, 9th, and 10th. Different grade levels have different tests, so we will use those 3 days to test 6th, 7th, and 8th graders. Next Friday is also prom for our juniors and seniors, so the ticket sales have been extended until this coming Friday. So if your juniors or seniors have not purchased tickets yet, they can still buy those at the front office. Wednesday, April 22nd, seniors will have a field day. Friday, May 1st is our next e-learning day, so students will stay home and work on assignments. Tuesday, May 5th is going to be our Federal Programs Parent Action Committee meeting at the Board of Education. So if you are an FPAC member, that will be held at the board this time and not virtually. Other parents, if you're interested in participating, please let us know because we will need volunteers for next year. And sports this week, you can see we have a lot going on. The end of March and early April is when all of our games and playoff implications come up. So we have an away game today. Middle school baseball is going to be at Minor. Tomorrow we have baseball here versus Cordova and soccer here versus Holt. There is an away softball game at Shades Valley. Also an away track meet at Centerpoint. There's nothing on Wednesday, but Thursday we have several things. Away games for baseball at Cordova, softball at JCA, and soccer at ACA. We will have a home middle school baseball game versus Oak Grove. And then Friday we have more away and home games. Baseball will be away at Carver. Soccer is away at Irwin and Chelsea. And then track is going to meet at the Archer Invitational in Georgia. The home game on Friday is middle school baseball versus Hueytown. Okay, now we have a video from Miss Godfrey's class. She sent this for students to watch and for parents to see what's going on in the biology class. She also teaches a chemistry class, so this can be used there. But since they were talking about cells, this osmosis is looking at that cell stuff for biology. So if you have a 9th grade student in biology, they are working on osmosis in class this week. We'll play this video and then we'll be back to answer any questions.
Right, today we're going to look at the required practical for osmosis, looking at the effect of different concentrations of solutions on some plant tissue, our plant tissue being a potato. And we'll talk more about the different concentration of solutions in a moment. But what I want to do first is prepare my potato, my plant tissue. To do that, we have a cork borer. And this is going to allow me to take samples from the potato that are all the same diameter, and that's going to be important so that I can compare my results more easily. So here is one cylinder. Now I'm going to cut 3 cylinders and I'm just going to set up 3 different concentrations of solution today. So 1 cylinder, 2 cylinders, and my 3rd potato cylinder. Notice these are all coming from the same potato. This should help keep my results more consistent with each other, easier for me to compare my results with each other. Now, what I want to do now is just going to cut the ends off. The ends of these, it's a potato skin, I'm just going to remove those. They are impermeable. They will not allow water into the tissue. That's not what we're looking for. This experiment is all about water either moving into the plant cells or out of the plant cells, and that's really what osmosis is. I've now got my cylinders. They are all the same length, which is fine, or approximately the same length, so again helping me to compare my results later on. But the instructions ask me to measure them into 3 centimetre lengths, so I'm just going to go with that. But they are all about the same length, which is fine. So I'm going to cut each one. Now I'm only using a ruler here. Not the most accurate way of measuring these, but we'll go with it. I'll talk about that in a moment. So I've got 1, 2, so that's again 3 centimetres. Getting as close as I can to 3 centimetres while using a ruler. 3. So I now have 3, as identical as I can get them, pieces of potato tissue. What I now need to do is measure them very accurately, as best as I can. I'm going to measure both their length using a ruler and also their mass using a top pan balance. So the ruler, I can measure them, and that one is exactly 30 millimetres. So they are all exactly 30 millimetres. Now I need to record those results. I need to make sure that I know the length of each cylinder if they're different. They're all the same in this case, so it doesn't really matter. So I need to record those in my results table. I then need to weigh their mass. So on this balance, what I'm using here is a balance that has 2 decimal places on it. So it is accurate to 100th of a gram. So I'm using a very high resolution top pan balance here to get a very accurate result. We're going to see probably very small changes in our mass here, which is why we need to use this piece of equipment, why it's appropriate. And we have a mass of 2.92 grams. So I need to record that in my results table. Having recorded the length and mass of this potato cylinder, it now goes in my boiling tube. Boiling tube, I need to place some liquid into it. Now I'm going to start with distilled water. So this is pure water. So this is our first one. So I'm going to put this in here. I'm going to get down eye level with the measuring cylinder, so I can measure very accurately 10 millilitres of distilled water. So again, I'm trying to keep everything exactly the same between all my experiments to help me to compare my results. So there's my distilled water. Very important, I now label this so I know what's in here. So I can't mix up my samples, which would be make it very hard to work out what's happened in this experiment. Because it's so hot at the moment, I am going to add a bung to this. Not necessary if we only do this experiment for a short period of time, or if the weather's not too hot. This will help prevent any evaporation of liquid out of the tube. So this is my first sample. I need to do that for my remaining 2 cylinders, adding 0.25 mole of sucrose. So this is slightly sugary solution. So it's got some sugar added to the water. So this is sort of slightly sugary water. And I'm going to add to another one 0.5 mole of sucrose. This is a stronger solution of sugar. And we need to see how these 3 solutions affect the potato. Now I have set some up earlier. I did this yesterday, allowing this to run for 24 hours to help my results hopefully increase a bit. So I should get bigger results than if I just do it for a short period of time. So Blue Peter moments, in come some that I made earlier. So I now need to collect my results, having left my samples overnight. And so we're going to show you how to do that. So I'm going to get my distilled water sample first, which is this one. Now I need to pour away the water. I'm going to collect the potato cylinder into a sieve. It's off camera, but I'm just going to pour it into a sieve. It's quite damp, it's quite wet, wetter than when I first got it from potato. So we need to remove the excess water on the outside of this that might affect the results. Quickest way to do that is very quickly roll it onto a green paper towel. It does not want to sit on the green paper towel. That could draw liquid out of the potato, which would affect my results. But I've now removed the excess liquid. So I now measure my length. Again, I'm using a ruler as I did before, and it has increased to 32 millimetres length. That's an increase of 2 millimetres. There is another piece of equipment we could use to measure length called vernier calipers. These measure length more accurately. So we could use these as an improvement to the experiment, but we're not going to do that today. I now need to measure the mass of my potato after it's been in distilled water for 24 hours. So onto the balance, and it is now at 3.12 grams. That's actually increased from 2.94 grams. So again, we have an increase here in our results, an increase in length and an increase in mass with distilled water. These results must be written down in your results table. So I've got to collect those results, and I need to do the same for the other two solutions. So 0.25 molar sugar solution. Again, so pour away the water, collect our cylinder, quickly dry it, measure the length, which is 30 millimetres, no real change there. Measure the mass, which is 3.06 grams, which is a very small increase. Yesterday's result, before putting into the sugar solution, was 2.96 grams. So a very, very small increase here. So having measured that one, I need to write my results down and move on to my third sample, which is the potato left in the strongest solution of sugar, 0.5 molar sugar solution. So again, collect my potato cylinder, quickly dry on the paper, removing excess liquids. Now I can actually feel this one is quite floppy compared to the others, which gives us a clue as to how our results may look in a moment. I measure the length. Hasn't particularly changed. It may have gone down very slightly. I can't really tell with the accuracy of this ruler. So the length may have decreased slightly, but I think that was about 30 millimetres. Hasn't really changed. Measure the mass, and the mass is now 2.62 grams. There's a decrease. Yesterday I measured this at 2.87 grams, so it has decreased in mass. So the other two samples saw an increase in mass. This one has decreased in mass, so there's a difference there. You need to be thinking about why the two different results have occurred. So we've now collected our results. The next stage is to think about what we can do with that data. So you need to calculate the difference in mass and the difference in length from yesterday to today. Some of them the mass will have increased, and for some of them the mass will have decreased. You need to work that out. Okay, so I've measured my length of my cylinders yesterday, and today I've measured my mass of my cylinders yesterday, and today my potato tissue. And we've seen there's some difference already. We need to calculate the exact differences. So what you now need to do is take your length today, your final length, and minus the initial length to get a difference. Has it increased or decreased in length? So you may get a negative number if it's decreased in length. You may get a positive number if it's increased in length. So you do the same for all three cylinders, then do the same for mass. So again, mass today, your second mass minus the initial mass. And again, you may get a positive number, an increase in mass. You might get a negative number, a decrease in mass. Unfortunately, because potato cylinders were not actually all identical at the start, now I did try very hard to keep them identical, but they were not all the same mass at the start. That makes it very hard to compare my results. What I need to do is a little calculation that makes it much easier to compare my results, a calculation called percentage change. So now you've got your change in results, you take that change in mass, so your mass today minus your initial mass, divide it by your initial mass, multiply that number by 100, and you have a percentage change. So again, if it is increase in mass, you should have a positive percentage increase, and if you have decrease in mass, you should have a negative percentage change. And some of the potato did increase in mass and some did decrease in mass. Now you should be thinking about why that has happened. If I did quite a few results, more than I've done today, you might get a graph that looks something like this. So here's one I've just sketched earlier. It's not particularly accurate, but it does show you the pattern you would expect to see. So you can see here, over here we've got our very pure water, and our potato should gain in mass. And as our concentration of sugar increases, so as we add more and more sugar, dissolve more and more sugar in the water, we increase the sugar concentration. You might talk about decreasing the concentration of the water. We might see that the results decrease. So initially, our gain in mass gets less and less and less. Notice the language I've used there. The gain in mass is decreasing. We then get to a point where our mass may or may not change. We might not see that in our experiment, but from a line of best fit, we can see there's a point where there is no change in mass. That's a very useful bit of information. This tells you actually how much sugar is within the potato tissue itself. So the water concentration, the sugar concentration within the potato is here. So we can estimate that by where this line of best fit crosses this axis. And then down here, so down below this axis, we have a loss of mass that is getting bigger and bigger. So an increasing loss of mass. So the more concentrated the sugar, the more water, the more mass the potato should lose. So that's down here. So this is what's happening down here. And that is osmosis.
Okay, so I hope you enjoyed that cool lab on osmosis using potatoes. We'll be logged in for about 20 more minutes. If anyone has any questions, you can just put them in the chat. And we'll be here monitoring, available to answer any questions.